Okay, here's 2.4, number 17. And it's the same as number 15. Determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why not. So here we have x equals 2. So we have this piecewise function. Again, so we have some issues at the juncture point, which is where we're looking for. All right. So it's equal to 1 over x when x is less than or equal to 2. And it's equal to 4 minus x when x is greater than 2. Okay. Kind of flip these around from the last example because it doesn't really matter. It's kind of arbitrary how you write these, where you can write the greater than or the less than first. Okay, add x equals 2. So a is going to be 2. And again, note that f of 2 is going to be 1 over x, or 1 over 2. That's what it's equal to 2. So remember, m is the slope. And the slope is this formula, which is a limit. The limit as h approaches 0 of f of a plus h minus f of a over h. So this is a limit. And remember, provided the limit exists. It always says that in the definition of the slope, provided the limit exists. So in order for the limit to exist, the left-hand limit must equal the right-hand limit. Both two-sided limits must be equal. So we need to check the left and the right-hand limits. Okay? So first of all, we check the left-hand limit. The limit as h approaches 0 from the left. And that's going to be this formula, f of a plus h minus f of a over h. And then we substitute the 2 in for h, minus f of 2. So this is going to be a little more complicated. 0 was easy in number 15, but this one's going to be a little more challenging because we're going to have to put that in. But remember, again, when I'm putting a negative here, this will make this negative. So this value will be negative. The value of my function will be negative. So or actually the value of my x, this is my whole x here. I'm taking the function of this. So 2 and h is going to be on the negative direction, so this will make this a little less than 2. If I'm really, really close to 0, I'm going to add a very small negative number to 2, so that will make that 1.9999, something like that. So it's going to make that a little bit to the left of 2, which would be over here. So if I'm to the left of 2, I'm using this function here. So I'm going to use 1 over x, which is 1 over, and my x is 2 plus h. Okay, that's because this is 0. I'm approaching it from the left. So again, I'm adding h will be a negative number, so I'm going to make this a little bit smaller than 2, so I'm to the left of 2, so I'm using 1 over h. Now when it's equal to 2, this is just f of 2, I'm not adding anything to it. F of 2 is again, just this function again, so that's 1 over. So I'm using the same function. So this is less than 2, this is equal to 2, so I'm using the same function. And now I just have to simplify this. So this is a little bit more complicated. This is one of those just do it where you have to, get rid of the complex fraction. So I multiply the top and the bottom by the least common denominator. So if I multiply this times the first term, what cancels? The 2 plus h, what's left? 1 times 2. When I multiply this times this term, because we have two terms, I got a negative here. And then the 2's cancel, and I just have 2 plus h. And when I multiply this times the bottom, I've got 2 times h times 2 plus h. Okay, let's kind of watch this. Now we remove the parentheses. We've got 2 minus h all over the 2h times 2 plus h. The 2's cancel, so I've got negative h on the top. Bottom stays the same. And then even if I try to simplify here, I'm going to have 0 over 0 because I still have an h in the denominator. So if I cancel h over h is 1, replace that by 1, I have negative 1 all over 2 times 2 plus h, then I can substitute my 0 now. And the 0 just makes that disappear, so I've got negative 1 over 2 times 2, which is negative 1/4. So that's the left-hand limit. Okay, hope you can see that. Okay, now the right-hand limit. This is the right-hand limit. So h is going to be approaching 0 from the positive direction, so I'm going to be adding a positive value to a. Or I'm going to be adding to a something. So a plus h minus f of a over h. A is 2, so 2 plus h minus f of 2 over h. And remember, since I'm going to be adding something, a positive to a over here, or 2 plus a positive is going to be a little bit to the right of 2. So I'm going to use this function, this part of the function. X will be greater than 2 because I'm to the right of 2, a little bit. Okay, so I'm going to use the 4 minus x over 4. Now the x is just this whole thing, so it's going to be 4 minus 2 plus h all over 4 minus 1/2. Because again, at 2, it's equal to 1 over x. Remember, it's equal to 2. It's 1 over x, or 1/2. So that's equal to 2, a little greater than 2. So we're using one part of the piecewise function when it's greater than 2, another part when it's equal to 2. And again, I've got a complex fraction, so I'll simplify this and I have to multiply both sides by the LCD. The LCD is 4. So when I multiply this by 4, these all cancel, so I got 4 minus 2h. There's my negative sign, and then I want to multiply 4 times a half. I get 2, and 4 times h is 4h. And I remove the parentheses, I got negative 2, negative h, minus 2, all over 4h. And negative 2 and negative 2 is negative 4, plus 4 cancel, so I just have negative h all over 4h. And h over h is 1, so that just becomes negative 1/4, and the limit of negative 1/4 is just negative 1/4. That's our constant rule. The limit of a constant, no matter what this is going to be a constant. And we notice that our limits are both the same. Our left limit and our right limit are the same. So therefore the slope does exist, so the slope of m equals negative 1/4. So I do have a tangent. And the slope is negative 1/4. So they say it does have a tangent, and if so, give it slope. The slope is negative 1/4. Both of these are the same. So the left limit equals the right limit. Okay? So I hope that helps. And look this one over. These are pretty tricky. We'll be dealing with these more in chapter 3, so this technique, so make sure you're up on this.